For question number 32, section D, and this section comprises of long answer questions of 5 marks each. And the first one is if a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, prove that the other two sides are divided in the same ratio. This is the BPT theorem, and we have to prove this. So let me draw a triangle. Let's say this is our triangle, and it's given that a line is drawn parallel to one side of the triangle. So let's say to intersect the other two sides in two distinct points. So these are the two. Okay, so this is the triangle, and line is drawn to intersect the two sides in points D and E. And so what is given is DE is parallel to BC, and we have to prove that the ratio of the corresponding parts of the sides that is divided by DE are divided in the same ratio, that is AD by DB is equal to AE by DC. That's what we have to prove. And for this, let's do some construction. And the construction is that we are going to draw DN or DN and EM perpendicular to AB. So this is EM. So construction is draw EM perpendicular to AB and DN perpendicular to AC. So, and also let's join D to C and B to E. And we have to prove now. So we have joined this. Okay, now let's find out the area of triangle ADE, ratio of area of triangle ADE and ratio of area of triangle BD. So triangle ADE, for triangle ADE, if I take base as AD, so half into base, and height is EM. For triangle BED, if I take base BE. Okay, now triangle BDE is an obtuse angle triangle. So this is an obtuse angle, so its height is outside, which is perpendicular to the side when produced. So BD is an obtuse angle triangle at D, and its height is EM, which is outside the triangle. So this is also EM. So EM, half gets cancelled, and now it's equal to AD by BD. Let's say this is our first set of equation. Similarly, I'm once again going to find out the ratio of area of triangle ADE, and this time it has to be the triangle DEC. Now ADE, this time I'm going to find the area of the triangle ADE by taking base AE, and height is EM, upon half into, for triangle DEC, base is EC, and it's also an obtuse angle triangle. So for obtuse angle triangle, so if this is an obtuse angled triangle, so its height is outside. So for this, the height is, for obtuse angle triangle, this obtuse angle at A height is DN. So this is okay. For AE, if base is AE, height should be DN, and for triangle DAC, it's AC half into EC into DN. So DN and half gets cancelled. So this is equal to A by AC. This is our second set equation. So we have almost got the result if these RHS are equal, but here it's AD and AD. So instead of these are making the difference, and if we are able to prove that these two are equals and these two sides will be equal, and we'll get our result. Now triangle BDE. So this is the triangle BDE and this is the other triangle DEC. And these are on the same base DE, and DE is parallel to BC. And we know that in earlier classes, we have studied that the two triangles on the same base, these are the triangles on the same base DE. This triangle BDE and DEC, they are on the same base DE and between the same parallels. So if triangles are between the same parallels and on the same base, then they are equal. So equal in area. So that means area of triangle BDE is equal to area of triangle DEC. This is the triangle because these triangles are on same base and the base is DE and parallel same base DE and same parallels DE and EC, and we know that the area of such triangles are equal. So now so this DEC will be replaced by BDE, and once it's replaced by BDE, we will get our LHS equal. This will make RHS equal. So instead of just writing this, we can just write from 1, 2, and 3 AD upon BD is equal to A by EC, and this proves our BPT theorem. Okay, now let's move on to question number 33, which has two parts.